It's less expensive than arc welding, than mechanical joining, and within its abilities, it is the quickest and most secure production process.
It is a low-cost form of joining metal that doesn't add a filler metal or a fastener of any type.
The end result is that your cost per weld is lower than with other types of welding.
Resistance welding is second to none when it comes to productivity and quality. Welds have superior strength and reliability. The process is economical and easily repeatable on the production line. Resistance welding has many distinct advantages. It's easy to automate. It produces strong joints. Tool design is usually simple and economical, and it works with a wide range of acceptable parameters. No additional materials are required. Maintenance schedules are predictable and uncomplicated. In addition, resistance welding saves money, lots of it. Individual welds are made in fractions of a second, increasing production rates.
Resistance welding is prevalent in many industries because it's a very cost-effective and simple technology to join two pieces of metal together.
There are savings in material. No waste due to extraneous metal like screws, rivets, filler rods, and solder, or use of fluxes and gases. Discussed in this segment are the key types of resistance welding: spot, projection, seam, and flash welding. Also demonstrated will be the functions and relationships of pressure, current, and time, and their application to the resistance welding. This basic spot welding machine will be used to explain the process. Pressure, current, and time are the main factors when making a resistance weld. Pressure forces the pieces of metal together. An electrical current passes through them. Time allows the metals to reach the proper temperature and fuse. The term resistance is used because the welding heat is actually generated by resistance to the flow of current through the parts. This heat then brings it up to near the melting point. This process is defined mathematically by Ohm's and Joule's law. During the squeeze portion of the welding cycle, the pressure increases rapidly, building up to full force. This forces the upper and lower electrodes together and holds the pieces of metal to be welded. The amount of welding force must be carefully controlled. Equally important, the welding force must be maintained throughout the entire welding process until the weld solidifies. After the current is turned off and the hold sequence ends, the pressure is reduced to zero and the electrodes open.
With the appropriate settings of pressure, current, and time, the joining of the two pieces of parent metal becomes stronger than the individual pieces.
A spot weld is made by clamping together two or more overlapping pieces of metal, while an electrical current is passed through a localized contact area to heat the metal to the welding temperature. This rapidly forms the weld nugget with the smallest carbon footprint of any metal welding process. In spot welding, the welds are made using copper alloy electrodes. The electrode's small face is the means by which the current and pressure are concentrated. Various shapes of electrodes can be used to fit the needs of the part to be welded. With resistance welding basics already reviewed, now is a good time to bring up the importance of quality assurance. Weld quality and appearance is frequently evaluated by measuring or inspecting the following: nugget size, joint tensile strength, and part appearance. In order to ensure consistent welds that meet or exceed the performance required for different applications, a program of regular testing is required. Standards and methods for testing resistance welds are available from the American Welding Society. Destructive sample testing should be employed when setting up a new machine or starting a new operation. One such test is the peel test, a quick and easy way to check for nugget formation and size. Here, the metal has sheared around the weld nugget. In some industries, more sophisticated testing is required.
It is very critical to ensure that quality is built into a product or a process, starting from design all the way through fabrication and final inspection.
Spot welding equipment includes rocker arm and press type spot welders, multiple spot welders, portable gun welding machines, trans guns, and automated welding systems. Rocker arm and press-type spot welders are the most versatile way to weld from the most simple to very complex parts in a wide range of metals. Multiple spot welders are a very useful and efficient family of machines, having the ability to produce many welds in a single machine cycle. Portable gun welding machines address several process requirements that cannot be met by either standard or dedicated multiple spot machines. Trans guns are an important variation of the portable gun, often mounted on a robot. Automated welding systems increase productivity and weld consistency. The design of an automated system is determined by many factors, including shape and size of parts, type of weld, and desired production rate.
Spot welding is used in automotive body, sheet metal work, aircraft, aerospace. Everyday life has to do with spot welding, even in your home appliances, refrigerators.
The focus now turns to the second resistance welding process, projection welding. With this method, the current and pressure are localized at a predetermined point by the design of the parts being welded. This is accomplished by a projection or an embossment on one of the work pieces. Nugget formation is very similar to spot welding. The projections collapse, bringing the surfaces together. The welding nuggets cool and the two pieces are joined. Projection welding has many advantages. Output per machine can be increased because several welds can be made simultaneously. Multiple projection welds are used where spot welding centers would be too close to make good welds. Examples are weld nuts and weld studs. Note the small projections on these parts. The use of projection welding produces uniform results in many applications, and the finished appearance is often improved. Another projection welding method is cross-wire welding, used to make mesh or other wire products such as refrigerator racks, wire baskets, and grocery carts. The weld is made at the contact point between two crossed wires and requires no additional machining or stamping. Projection welding machines can be made with many variations, each adapted to enhance the production efficiency of the parts being welded. The third resistance welding process is seam welding, taking on the task of welding products that need a continuous weld. Like other forms of resistance welding, seam welding deals with the basic principles of joining metals by applying force and passing current for a length of time through the metal area to be joined. Seam welding consists of making a series of spot welds by means of one or two rotating wheel electrodes, without opening the electrodes between spots. External cooling is often used in the process. Standard type seam welders are built on press type frames similar to spot and projection welders. Welding wheels are mounted on shafts rotating on bearings that carry an electric current. The fourth resistance welding process is flash and upset welding. They differ from spot, projection, and seam welding in that the ends of the two pieces of metal are welded together. A common example is the entire edge of a wheel rim cylinder flash welded, or two ends of a rod or flat stock upset together. In flash welding, the two pieces or edges are placed in clamps where they are held adjacent to each other. Welding voltage is applied and the parts are moved together at a controlled rate. This causes arcing or flashing between the two surfaces, creating a heat-affected zone until a forging force is applied. Upset welding is similar to flash welding. However, the two parts remain in constant contact, creating the heat-affected zone until a forging force is applied.
Resistance welding is one of the areas where in welding that's not as well known, because most people think of an arc weld, stick welding, or wire welding. But in most factories, there are some type of spot welding or projection or seam or flash butt welding. It's economical, it's high speed, doesn't take any filler materials or gases, but again, it's a very clean process.
There are a few other resistance welding methods to quickly mention. To weld non-ferrous metals, including copper, silver, and tungsten, the resistance brazing method can be used. Similar to gas or furnace brazing, this process often uses a bronze, silver alloy, or brass filler metal to bond base materials together. Electrodes used in resistance brazing are often made of carbon, graphite, molybdenum, or tungsten. In resistance parting, electrodes heat a cable or bar, which is then separated midway between the electrodes. With the basic resistance welding processes covered, the next segment will discuss how these processes are applied in many industries to create thousands of different products and services used in everyday life.